Welcome back, guys. We are starting Unit 8 today, which is all about something called radicals. Now, let's get right into it. To solve this equation, x squared equals 100. The first thing and the only thing we need to do is get rid of the squared. And then we have x alone. Once we got x by itself, we know we've solved it. So, okay, well, think to yourself, well, how do you get rid of squared? Okay, well, if you don't know, to get rid of a squared term, you use the square root, or which is like that symbol right there, which we've all seen before. This is called a square root, but this is also called a radical. And that's all what this unit is about. It's all about radicals, or square roots. Now, just like addition undoes subtraction and division undoes multiplication, realize that taking the square root of a number undoes the squared term. So square and square root are like inverse operations. They undo each other, just like addition and subtraction. Now, when you take the square root of a number, you're really just asking yourself, what number multiplied by itself equals this number that I'm talking about? Okay, that's super wordy. It's not as complicated as all that kind of makes it sound. So let's just break it down. To solve this for x, to get x alone, I have to get rid of the squared. Okay, we mentioned up here to do that, you square root. Square and square root cancel each other out, and you would just have x. Whatever you do to one side of an equation, you have to keep it balanced and do that to the other side. And once I found the square root of 100, that's my answer for x. Now, square root, like I said, just means what number times itself equals 100. Well, I know that 10 times 10 equals 100, so the square root of 100 is 10. Now, that one's pretty easy, and today we're just going to be simplifying radicals. Like, I'm going to ask you, what's the square root of 100? What's the square root of 16, 36? These first examples are easy, and the reason they're easy is because these numbers underneath the radical are called perfect squares, which means it works out to be a nice whole number. Hopefully you know these perfect squares off the top of your head. If you don't, let me show you how to type in a square root into your calculator if you don't know that. If you look at the x squared button, most of you guys have this calculator, above it is the little square root symbol. So since it's above the button, you have to press second and then x squared, and it'll bring up the little square root, and then you just type in the number. Most of you guys know, though, that square root of 16 is 4, because 4 times 4 equals 16. And again, the square root just means what times itself equals that number. Well, I know that 6 times 6 is 36, so the square root of 36 is just 6, and the square root of 121 is 11. Hopefully we know those. Those are pretty basic, pretty straightforward. Now, if I were to make a list of all the perfect square numbers, let me do that here. This might help us as we move forward to more complicated examples. So, perfect square numbers. Well, let's start at the bottom. 1 times 1 is 1. So 1 is a perfect square. 2 times 2 is 4. So 4 is a perfect square. 3 times 3 is 9. 4 times 4 is 16. If I kept kind of going with that pattern, here's all my perfect square numbers, so on and so forth. Now, these are easy. Most of us can do these, no problem. Here's where new stuff comes in, Algebra 1. What if I asked you to simplify, or like tell me what something like square root 50 equals? Okay, here's the problem. This is not a perfect square. If I type this into my calculator, I get a decimal. It's like 7 point something. Okay, well, the problem with simplifying is you want to have like an exact answer. I can't write this. This goes on and on forever, so I want to simplify this a little bit nicer. No decimals. So here's what you do if you are asked to simplify a radical, something with a square root, that's not one of these perfect square numbers. There's two methods to doing this. I'm going to show you both ways, but I want to point out that the second method, which is called the factor tree method, that's what I use, and that's what I'm going to have you guys use. Students over the years have better luck with this method, so that's why I picked this one. But here's how you would do the first method, which is called the biggest perfect square method. Okay, so say I want to simplify square root 50. What I have to look for is what's the biggest perfect square numbers, so out of my list here, what's the biggest one of these numbers that's a factor of 50. Okay, so if I kind of go down the list here, it's 25. So here's how I would rewrite this. I would write 50 as 25 times 2. 25 times 2 is the same thing as 50. And then what I would do is I would break up the radical, and I would give 25 a radical, and I would give 2 its own little radical. And then I know, oh yeah, the square root of 25, that's a perfect square, that's just 5. And then if you bring down the square root 2, there's no perfect square number that goes into 2 besides 1, so that means it can't be simplified. Okay, so 5 square root 2 would be a simplified answer for square root 50. And check it out. If you type in 5 square root 2 into your calculator, you can see it. That's that same decimal, 7.07, blah, blah, blah. Okay, so it's the same thing, the same number, it's just written in a more simplified way. Now, this is the method, like I said, I'm going to use. The reason I like this method better is because I don't want to sit here and look at this list and figure out what's the biggest number that goes into whatever number I'm trying to simplify. Factor tree method, maybe it's a little bit more work, but you don't have to think as hard. So here's how this method goes. What you do is you break down 50 into like a little tree thing. And your tree is just consisting of factors of that number. So I would think to myself, all right, what can I multiply to get 50? I can do 25 and 2, I can do 5 and 10, doesn't matter what you pick. Okay, so here's how you do the tree. Every number that's prime, you circle it. I'm gonna make a little note. Circle prime numbers. Prime means you can't break it down any further into factors besides like 1 and that number. There's nothing I can multiply by 5 besides 1 and 5. So I circle it. But I can keep going with 10. I can do 2 times 5. I cannot break down 2 and 5 though into any other factors besides 1 times that number. So I'm going to circle those two. So once you've broken down 50 into all the prime factors that are circled, here's how you use those numbers to rewrite your radical into the more simplified version. So, and I'll make a note of this off to the side, but let me say it first. So I know I'm trying to write like some kind of radical number. For every pair of numbers, you're going to bring one of those out front. So look, here's 5 and 5. There's a pair. And I like to cross them off so I don't like forget about it or forget that I haven't used it. So for every pair, I bring one of those to the front. There's 2 5s, so I bring one out. The reason you can do that is because 5 times 5 is 25. So that really is just looking like 25 underneath, which I know the square root of 25 is just 5. Okay, so every pair, pull one out. If it doesn't have a pair, like the 2 here, then you leave it underneath. What do you know? We got the same answer. It's the same 7.07 decimal. It's just a different way to write radical 50 using radicals. Okay, let's make one more note before we practice. So I'm going to say for every pair, 1 comes out to the front. Couldn't hurt to make those 2 little notes there. Hopefully you can read my handwriting. Okay, so we just got practice. That's how you get better with this stuff, so here we go. So number 1, again, I'm going to stick with this factor tree method. So I just need to break down 98. Don't think about the biggest perfect square number. You just got to find 2 numbers that multiply to be 98. If you're struggling to do that, I always think to myself, oh, this number's even. If it's an even number, that means 2 goes into it. 2 times 49. 2 is prime, circle it. And 49 breaks down into 7 and 7, which are both prime. So I circle those. Okay, here's how I rewrite it. I get my radical going. For every pair of numbers, so here's a pair of 7s, I bring 1 7 to the front. The 2 is very lonely and sad. He's single. He has to stay underneath. Wah, wah. That's the answer. 7 radical 2. Okay, number 2. It's the same process. There's something that's a little different, though, here. So let me do the factor trees first. Then we'll address the fact that there's a 3 randomly sitting outside the radical already. But let's concentrate on breaking down 108 first. So maybe you don't know what goes into 108 off the top of your head. But again, I see that it's even, so I know 2 goes into it. So I could do 2 and 54. 2 is prime, but 54 I can keep going. That's even, so divide it by 2. 2 times 27. And let's see, 27 can go 9 and 3. And 9 can go 3 and 3. Circle your prime factors, otherwise I guarantee a number is going to get lost. You don't want that to happen, you won't get the right answer. Okay, so let's bring my radical out here. And here's where this comes in. And I'll kind of show you how I start the problem next time, like right away so we don't forget about it. There's a 3 that's already there. So all you have to do is just make sure to bring that 3 down. You just can't forget that it was already there. Okay, so bring that down. Now let's figure out what comes out front for my factor tree. So I see a pair of 2s. That means 1, 2 comes out. And guys, if numbers come out together, you multiply them. Now I have a pair of 3s, so a 3 comes out. And that's going to get multiplied in. This 3 doesn't have a pair, he's single, he stays underneath. Okay, so I can make this answer better by multiplying all the numbers that came out front. So 3 times 2 is 6, 6 times 3 is 18. So 18 radical 3 is the better way to write this radical right here. So honestly, guys, I know you're probably thinking like, oh, well, what's the point? This stuff is, I know it's like kind of just testing skills. It's like kill and drill, like just one thing over and over again, practicing the same thing. But this is such a necessary skill for algebra. You do this also in geometry and in algebra too. Like this stuff does not go away. So right now it just kind of seems like dull practice, but it is a skill that you absolutely have to be successful in math. So we gotta learn it. Number 3, I want you to try on your own. You're also gonna try number 8. So I'm gonna circle those right now. Okay, number 4 is like 3. Here's what I do right off the bat. So I don't know my final answer yet, but I know I'm gonna have a radical there. If I see a number out front, I bring it down right away. Otherwise, there's a really good chance I'm gonna forget about it. Bring down the -2, then let's factor tree 175. It's not even, but I do know that 25 goes in, and 5 goes in, so maybe I just do 5 and 35. 5's going to go into 35, obviously 7 and 5. Hopefully you didn't need to use your calculator for that. Okay, I see a pair of 5s now, so 1 5 comes out, and it's going to get multiplied by the -2, and the 7 stays underneath. So the best answer is, when I multiply -2 and 5, -10 radical 7. All right, now we get into some that have like multiplication going on. So 5 and 6 kind of look similar, but here's what you want to do. If they give you a problem where both of the numbers are underneath the radical and they're asking you to multiply, what you want to do is you want to make this one radical first. I don't want to do more than one factor tree. I only want to do one. So let me multiply these numbers together and say radical 40 is what I'm going to factor tree. Okay, so let's break that down. Let's see, and I can break it down into 5 and 8, what I multiplied to get it. 8 would go 4 and 2, and then 2 and 2. Okay, so let's see, I see a pair of 2's, so I bring a 2 out. And then 2 and 5 would stay underneath, and if two numbers stay underneath together, you multiply them. So that'd be 10. Notice that I like to cross the numbers off. Again, I'm mentioning that fact again. If you do not cross them off, you will probably forget about something. So definitely recommend crossing off after you account for those pairs. Number 6, realize that you cannot multiply 14 and 9 together like you did number 5. And the reason is the 9 is not underneath a radical. So you cannot multiply radical numbers and plain numbers. The only thing you can do is just like press them against each other. And they'll always write the plain number and then the radical number. So I'm just going to put the 9 in front. That's technically my answer. You always want to see if you can make this more simplified. And to do that, you would see if you could factor tree the number underneath the radical. So 14 breaks down into 7 and 2. Those are both prime. If you find a case like this where there are no pairs, then you just can't bring anything out front. So that means that it can't simplify. Or 9 radical 14, that's just your answer. So that one's kind of nice. Okay, so number 6 here. This is the same kind of thing as 5. I have 2 radical things that need to be multiplied, except this time you have numbers out front and numbers underneath. So here's how you're going to bring this together. And my suggestion again is to make this one radical first. You can multiply the numbers out front. So 6 times 3 is 18, and that will be your new number out front. And you can multiply the numbers underneath. So make this one radical expression first. Then see if you can factor tree this down to make it better. So I could do 10 and 10, 5 and 2. Okay, again, do not forget if there's a number out front that it needs to come down. Ooh, that's going to drive me crazy, that color change. All right, notice this. Let's see, I've got a pair of 5s, 5 comes out. I got a pair of 2s, 2 comes out. If nothing is left underneath, you don't even write the radical. You're just going to multiply all these numbers. So that's 10 times 18 is 180. The reason that there was no radical left is because 100 is a perfect square. So if you could have seen this right away, like, oh, square root of 100 is just 10, so that's just 10 times 18, boom, 180. All right, I want you guys to try number 8, and then I'll finish with number 9. Ooh, the formatting got weird here. Cross off that 6 in the parentheses. That's not supposed to be there. Same idea though, if you've got 2 radicals being multiplied together, make it one problem first. 5 is the only number out front, so can't be multiplied by anything, but I can multiply 6 times 3. Okay, I start my answer right away, and I bring the 5 down so I don't forget about it. Then let's break down 18. Maybe I'll go like 9 and 2, and then 3 and 3. I got a pair of 3s, so a 3 comes out, 2 stays under, and that leaves me with an answer of 15, radical 2.